You are watching this video because you want to learn more about vacuum cleaner performance. The vacuum cleaner industry is a competitive market. Sales brochures are rife with exaggerated claims. You'll come across obscure definitions. Manufacturers will use confusing performance measurements that mean nothing to the consumer. Cana-Vac would like to help you navigate this information maze by answering your questions about central vacuum cleaner systems. So you can comparison shop and make a well-informed purchase decision. It is our hope, regardless of the brands that you choose, that you will find a quality central vacuum cleaner that will make you want to tell your friends and relatives, now and for many years to come, that you love your central vacuum cleaner. Have a look at these 3 vacuum cleaner motors. Which motor do you think performs best? Want a hint? There are 3 magical marketing terms that vacuum salespeople use to measure vacuum cleaner performance. The first magic word is air watt. An air watt is a unit of power determined by a mathematical equation. Here it is. An air watt equals suction, measured in inches of water lift, times air flow, measured in cubic feet per minute, divided by 8.5. However, air watt measurements can be misleading. Sometimes smaller motors may claim to produce higher air watts in their product brochures, but brochure air watts are measured at the motor and not at the end of the hose. This measurement has nothing to do with vacuum cleaner performance. Simply put, air watts is a term salespeople use to blind customers. For example, tiny flow-through motors may be hidden inside what appear to be large units. You could be paying a high price and getting less than what you bargained for. Before you make your purchase decision, ask the salesperson to open up the canister so that you can see the motor for yourself. But let me repeat what I said before. Advertised air watts do not measure vacuum cleaner performance, because brochure air watts do not account for performance-robbing restrictions such as filtration. Piping is another factor that will lead to decreased performance. What about the power head? The style and age of the power head may contribute to performance loss. Finally, the hose. Obviously, the length of the hose will impact the vacuum's performance. What happens when the air watt measurement is taken at the end of the hose? Good question. When measured at the ends of the hose, a smaller motor with less suction will have a lower air watt measurement than a larger motor with more suction. So you see, brochure air watts are not a very good way to evaluate the best performance or value of a vacuum system. The second magic marketing term that vacuum salespeople use to measure performance is airflow. Airflow is measured in cubic feet per minute. This measurement tells how much air the central vacuum motor can move. Imagine your central vacuum motor is like a jet engine. Turbine propellers are spinning at thousands of revolutions per minute, generating tremendous suction and producing a huge amount of airflow which is then exhausted. A central vacuum motor operates along the same principle. When airflow is at its maximum performance at an open, unobstructed orifice, suction is at its weakest. However, as the orifice gets smaller, suction increases. You might compare this to walking between 2 city skyscrapers on an otherwise calm day. Between the buildings, you will notice a big increase in wind speed. What you need to know is that airflow and suction at the end of the hose work together to clean floors. More suction, better airflow. That is why systems with more suction offer better end-of-the-hose cleaning performance. And this leads us finally to our third magic marketing term, suction. Suction is measured in inches of water lift. This is determined by sucking a 1-inch column of water vertically to its maximum height in inches. So, we've talked about air watts and airflow, but suction is what is really important. A motor with greater suction will deliver better performance at the end of the hose. This is where size matters. There are many vacuum cleaner choices available, but the quality and longevity of each depends on the motor. A central vacuum motor consists of several parts. These include motor carbon brushes that conduct electrical current, the armature, which converts electrical power to mechanical torque, the field, which is the magnetic component of a motor, and the intake fans. Typically, more intake fans, the greater the size, the greater the performance. Do you remember we asked you which of these 3 vacuum motors performs best? These 3 motor types are called the flow-through motor, the peripheral bypass motor, and the tangential bypass motor. A flow-through motor is the most affordable, but it typically has the shortest life expectancy, does not have a dedicated cooling fan, and uses exhausting air to cool the motor. This is a good motor, but the least desirable of the 3. A peripheral bypass motor is a motor with a dedicated cooling fan that blows fresh, clean air over the armature and exhausts it through small vents around the side of the motor. This motor is a better option, but it also exhausts heated air around the motor, which can affect motor life. The third type of motor is the tangential bypass motor. This motor is the largest, most powerful, and generally the most reliable. Dedicated clean air cools the motor, while the tangential exhaust expels all heated, dirty air from the motor chamber. This motor can vent 100% of allergens and pollutants out of your home. This is by far the best option. So, now that we've told you all about vacuum cleaner performance, how it's measured, and the types of motors, let's go back to our original question. Which of these 3 vacuum cleaner motors do you think performs best? If you guessed this larger tangential bypass motor, you are correct. Congratulations!